Good morning, everybody. Hopefully you're ready for another sunny day of chemistry with your host, me, Dr. White. Hi. On Wednesday, I was talking about the electrons. Remember the subatomic particles, there are three of them: protons, electrons, neutrons. I won't make you do class participation. Won't ruin your weekend. But anyways, those are the three, and the big question is, if the protons and neutrons are in the nucleus, the center of an atom, where are the electrons? And I started talking about electron shells and subshells. And an electron shell is the area around the nucleus where it's approximately the same distance, and electrons in there have approximately the same energy. And then each shell has what's called subshells. And there you have a region around the nucleus which contains electrons that have the same energy. Now, one of your colleagues yesterday after lab asked a pertinent question, said, what you did on Wednesday at the end, I don't understand it. I'm confused. And that's a good question to ask, because I knew and I told your colleague, well, I just started talking about it. Trust me, I'm not done. And that's what we'll do today. Now, when we talk about shells and subshells, the electron shell has a name. It's a very complex name. And the first shell is called 1. It's difficult. Second is 2. Next one is 3. And the last one, 4. I think there might be 5. And then an important thing to know is shell 1 has 1 subshell. Shell 2 has 2 subshells. Ooh, it's even on the screen. And shell 3 has 3 subshells. And finally, shell 4 has 4 subshells. What's not on the screen that you should remember shell 1 has the lowest energy electrons, then shell 2, shell 3, and 4, and shell 4 has the highest energy. And next, when we talk about subshells, they're given names, actually letters, S, P, D, and F, and you don't have to know about it, but S stands for sharp, P stands for principal, D diffuse, F fundamental. And when they were doing atomic spectra, they had different lines and different intensities, and someone came up with those, how should I say them, unique names. Obviously the first one was very sharp. I don't know how they came up with that. That was long before even I was born. And an important thing, which I'll go about in the next slide, S is the lowest energy, P, then D, and F is the highest. Is everybody familiar with the less than symbol? Okay, just checking. Now, when it comes to the subshells, technically these are lower cases, pretend they look like lower case. Subshell S, the maximum amount of electrons you can put in there is 2. And then P has 6, D 10, and if you notice, F 14. And this was all determined by experiments that chemists did in the lab, determining these values. Same thing with the energy levels and the different shells. These are all done by experiments. Now, I've been reviewing something. Orbital, I'm not going to cover again because I'm not going to have it on the test or the final. And the important thing from this slide you should remember is electron subshells are filled in order of increasing energy. And again, I'll put this up here. And S has the lowest energy, then E, D, and F is the highest. Now, the question is, where are the electrons? If you have an element, where are the electrons? Remember the atomic number, the number on top, tells you how many electrons and protons there are in that element. And therefore, we have to, the next 2 bullets, let's ignore for now, and for later too, because I'm not going through orbital diagrams. The question is, how do you find where the electrons are? And the electrons are determined or shown one way by what's called electron configuration. And if we ask the following question, those who haven't figured out how to read my handwriting, I'll translate it. And that is 3 points each. Write the electron configuration for, and the first one is A, lithium. Well, how do you do that? Because I don't know about you, but when I took a test, I wanted all the points I could get. Let's get out our trusty periodic table. The first thing you have to know to do this problem is, what's the chemical symbol for lithium? You don't have to write this down, but you have to know it's Li. Next, you need to know how many electrons are in lithium. And you have to find it on the periodic table. It's an alkali metal in the first column. The atomic number is 3, which tells us we have 3 electrons. Now, the question is, where are they? Now, let me show you something, and one of the things that at my level, you learn about is you don't take credit for somebody else's idea. I forgot which book I saw this in a while ago, but this is a good time to do this. Oh, by the way, warning, Dr. White artwork is different. All right, assume this is a drawer, dresser in your bedroom, or wherever in your house, a cabinet with drawers. So we'll call that drawer 1, 2, 3, 4. And being a lazy person I am, I'm going to put stuff in drawer 1 first so I don't have to bend over, and I'll fill that first. Now it turns out drawer 1 has a box that you put stuff in. And I'll call that box S. And you can only put 2 things in S. Now, drawer 2 has 2 boxes, S and P. and you can only put 2 in S and 6 in D. And 3 has 3 boxes, S, P, and D, and 4 has 4 boxes, which I won't draw, and I'll explain a little while why. So, think of being lazy, and you don't want to have to bend over, and so I'm going to fill the first drawer first. And if I have 3 things in drawer 1, how many things can I put in? Because I can only put in what's in the box in drawer 1. I can only put in 2 things. Let's call them electrons. And therefore, I have drawer 1, and in drawer 1, there's only 1 box we call F, and the most I can put in there is 2. I've got 3 things to put in. I put in 2, I have 1 more to go. Well, drawer 1 is full. I have to go to drawer 2. I put in the first box, always in S, which we call number, letter, 2S. It's like here, number, letter, 2S. How many things do I have? Electrons left to go. 1. So I'm going to put it in this box right here. I can put 2, and that's how you do electron configuration. Then you keep on moving down. Think of it like drawers. I don't know if that makes any sense or helps you, but let's try another one. So the answer here would be, you fill up the first shell has 1 subshell. That's what this tells us. The first shell in every subshell in every shell is always S, and therefore in 1, I have 1 S, and that's how you name a subshell. Number and letter, I can only put 2 in there. I filled it up. So this drawer or shell is filled up. I'll now go to the next one, and the first box I put in there, really called subshell, is 1, or there's S, and I can put 2 in there, but I only have 1 electron left, so I'm done. Ooh, let's do another one. These are fun. Now you know I'm a chemist if I say these are fun. And the same question, 3 points each. Write the electron configuration for carbon. So how do you do that? Well, you figure out, you know what's the chemical symbol for carbon, C. Now we have to find how many electrons carbon has. We come over to the periodic table, we find carbon. This is the actual one you'll be given during the test. Most of you can't see that one. I'll ask you not to look at it, honor principle. And if you look in the upper corner, it has number 6, and that tells you you have 6 electrons and 6 protons. We're dealing with the electrons. And now, what's the first place I put the electrons? The first shell, which is 1, which only has 1 subshell, 1s. How many electrons can I put in 1s? 2. So this shell is full, like the drawer. The next shell is 2, my second drawer. What's the first box or shell, subshell? S. How many electrons can I put in there? 2. Am I done? No, I have 6, and I've only done 4, so I got 2 more to go. Now, how many subshells does shell 2 have? 2. So now I filled the first one, S. The second one, because you always go from lowest, is 6, or P, and you use a number, 2, and the letter P. How many can I put in there? 6. How many do I have left to go? Well, you got to use your high-level math and do it in your head and take out your calculator. 6 minus 2 plus 2 is 4, which is 6 minus 4 is 2. And I'll put it in there. I could have put more, but that's all I have to do. And that's how you do it. You always start from the lowest energy shell and the subshells and you go down this way. In case you haven't learned them, nitrogen is N, and I'm going to share the fun. You try and write the electron configuration for nitrogen. You haven't figured out. That's right. Remember, when you're done, look up and smile. Oh, it works. I don't think it would be fun if I said look up and frown. All right, anybody need more time? Let's do it. First of all, in order to figure out this, you have to know the chemical symbol. It's nitrogen. Again, hopefully you've learned those 37 I asked you to learn. And next, where is it on the periodic table? Nitrogen's there. Then, how many electrons does nitrogen have? We look in the upper corner and it says 7. And the atomic number tells you how many protons and electrons. So I have 7 electrons. On a test, do you have to write this down? No. But I will give you this piece of advice that's worked for me. And trust me, by the time I got my PhD, I've taken more tests than you've ever taken at this point in your career, and quite hard ones. And one of the things I found is, the more you let the paper do your thinking, the better scores you get. I didn't know paper could think. Yes, it can. In other words, instead of keeping this in your head, just write it down. I give you plenty of room, and the first test, which I wrote last night, I rewrite it every semester because I let students keep the test to use as a study guide for the final. It has 7 multiple choice, but it has other questions that are like this, and you have room to write it down. So all right, let's continue. We have 7 electrons. What's the first shell we put it in? Top cabinet, if you want to remember this, or shell, and that's 1. And what's the subshell? S. You name a subshell by number, letter. How many electrons can I put in one S? Good, son. By the way, this and this will be given to you in important information. A couple years ago, I used to make the students memorize this, and as you know, I no longer am testing your memorization skills, but your chemistry skills. All right. How many electrons can we put in one S? 2. Am I done? No, I have 5 more to go. Well, how many subshells in 1? 1. That's 1S. I filled it. Now I have to go to the second drawer, or shell, and that's 2. And it has 2 subshells, S and P. You always start lowest and keep on going down. So the first subshell in 2 that I fill up is 2S. How many electrons can I put in 2S? 2. Am I done? No, because I have 7 electrons and I've only shown 2 plus 2, 4. So I have 3 more to go. How many electrons can I put in 2S? 2. Well, I'm full. So this box is full, and I have to go to the next box, or subshell in 2, because 2 has 2 subshells, S and P. So how do you name a subshell? Number, letter, 2P. And now, how many electrons can I put in 2P? Any P orbital, the subshell, you can put 6. Well, how many do I have to go? 7 minus 4, plus 2 is 4, I got that right, and that would be 3, and I'm done. Everybody with me? We'll do one more, but first, let me show you something interesting. Don't you love Google? Now it turns out when you get to the higher elements, life isn't as sweet as I've shown you. There are variations, or not really violations, but changes in the rule. And if you notice here, you fill 1s, then 2p, 2s, 2p, then 3s, 3p, 3d, or wait, yeah, 3p, then 4s, and it's not always straightforward. And you say, what happens? I guess the term is exceptions to a rule. It gets really complex. Well, guess what? First of all, I'm in a time for a Dr. White gift. And what is that gift? If we go over to the periodic table, for my test number 1 and the final, I will only hold you to know how to do up to magnesium electron configurations. And up to that, a little higher, but up to that, everything works fine, just like I showed you. When you get down to things like krypton or O's, it changes. Sometimes you'll have a 3s before a 4G, a 4s before a 3D, and so on. There's a bunch of exceptions to the rule. And guess what? It's not worth your time to spend 2 weeks learning something that you'll probably get wrong on a test. And I'll be honest with you, I don't need to know those rules, because there's something more important that I will teach you with electrons. So let's do one more. I'll let you do it solo, and then I'll do it. Do the electron configuration for sodium. For those who haven't learned it, hopefully you will, the chemical symbol for sodium is Na. It's an alkali metal, which is something you should learn for test number 1, and it's right here. If you notice, I still won't be a hand model for TV. You can tell my nails are done professionally, not. Remember, think of like filling the cabinet or dresser drawers. All right, looks like all the electrons are down. Anybody need more time? Let's do it. All right, first thing you have to do is figure out how many electrons are sodium. First, you have to know the chemical symbol, sodium. Sodium is Na, it's right there, and the atomic number 11 tells you how many protons and electrons. We're interested in electrons, so I have 11 electrons. And a pen that's going dry on me, so let's change it. Now, what's the first shell you put the electrons in? 1. What subshell? How many subshells 1 has? Only 1, and that's always you start the lowest energy, S, and that's called 1s. How many electrons can you put in 1s? Or 2s or 3s, but we're talking about 1s now. 2. Well, I've got more to go. How many subshells does 1 have? 1. It's right there on the board. It must be true. But anyways, that was a lame joke. I've done it twice already this week. I'm trying not to again. But anyways, and it has 1 subshell, S, 1s, and we put 2 in there. So we're finished. This is full. Now we have to go to the next shell, which is 2, because 1 is full. And the first subshell of 2 is 2s. Always start at the lowest. How many electrons can I put in any s orbital? 2. And now, am I done yet? No. I have 7 more to go if I did my math, 11 minus 4. So, how many subshells does 2 have? 2. What's the second one? P, 2p. How many electrons can I put into 2p? 6. I'm going to do that because I now have 2 plus 2 is 4 plus 6 is 10. Ooh, I still have 1 more to go. Now, how many subshells does shell 2 have? 2. S and P. And I fill them up. I'm going to make some more room here because I'll need it. And therefore, shell 2, its subshells are filled up. I have 1 more electron to go. What do? I go to the next shell, which is 3. Think of like a drawer. And what's the first subshell of 3? 3s. And 3s, I can put how many electrons? 2. But how many do I have to go? 1 more. And final check, do I have 11 electrons up here? 2 plus 2, 4, plus 6, 10, plus 1, 11. I'm done successfully. And that's how you do electron configurations. Now, when we do chapter 3 problem set, I'll do more of these, or you'll do them first. And I'd highly recommend you try it on your own. Remember what I said about the first day and the Blu-ray of the bike? When I do it, it doesn't look that hard. When you're at home alone and you've got to do it, first 1 or 2 times, you're going to struggle with it. And then once you get the hang of it, by the way, on Blackboard, all the answers for the problem sets are there. Ooh, special announcement from the management meeting. Next week in lab, Tuesday and Thursday, I will go through the problem set, let's see, chapter 2, and the problem set for appendix A2 and A4. And this way we're kept on track, and you'll be in good shape for test number 1, which is coming up soon. I'll talk more about that. And that's the electron configuration. And switches off for this slide. There's another way of showing where the electrons are, and that's called the orbital diagram. And notice it's written on the screen, your slides. This will not be on the test or the final. It's another way of showing it. I used to do it in here, and I realized I never use it. You'll never use it. Well, I have better things to teach you. So we're going to skip that. All right. The switch is on. If the switch was a dial and it only went up to 10, I've just turned it to 15. This is very important. Now, not all electrons are created equally. And there's special electrons we call the valence electrons. And the valence electrons are the outermost electrons of an atom. Oh, once again, it's time for Dr. White to be very subtle. Now you know I'm serious. And you should know the key way of thinking of it is the valence electrons are the outermost electrons of an element. And I'll teach you that how do you find the valence electrons? Those are the electrons based on group number at the top of the periodic table, which I'll teach you in a little while. And notice, even on the slide, I have know this, the top part. And also know the second one I'll teach you. I'll never ask you how do you find valence electrons, define it, but I'll ask you to know how to do that in the test, and you'll see that in a second. These are the most important electrons. And the question is, why are you getting all fired up on this? Why are they so important? Well, when you make things, like your skin, what's left of my hair, your food, or anything else you see in here, made up of atoms that make molecules, which I'll teach you about, how does that happen? Two things come together, atoms, to make a molecule. And what holds them together, I'll be teaching you, is called a chemical bond. And those involve the electrons. Guess which electron? The valence electrons, because when two atoms come together, the outermost electrons are the ones that interact and form the bond, chemical bond that holds atoms together that allows us to have water. But you never thought of water as a chemical. It is. It's made up of atoms held together, and it's the valence electrons that hold them together. And unlike this, which I never used that much in my career, valence electrons are most important, and I know them as good as I know my first name. You know quite well. So let's look at how you determine the valence electron. Remember, the valence electrons are the outermost electrons, and you see the hint over there. You should know that definition. Jim? I told you I can be subtle. Now, you don't have to copy anything down from here, but you should know some stuff from here. The representative elements in the same group, which means the column, and I'll show you the periodic table in a second, have the same valence, number of valence electrons. The valence electron, number of valence electrons are for representative elements in a group, meaning all the elements in a column, are the same as the Roman numeral, or since, how many of you know Roman numerals? You don't teach that in school anymore, really. I have the regular numbers too. A couple years ago when I found out students weren't learning Roman, how do you know when you see the end of an old movie, what year it was made? It's always in Roman numerals. But anyways, you don't have to know that, but the number on top tells you. Now, important thing is you can only have maximum of 8 valence electrons. All the elements there, the maximum is only 8. And some have, a lot of them have less, but the maximum is 8. Wow, time flies when you're having fun with electrons. Oh, good, it's valence electron practice time. Now, here we have the periodic table. Let me bring it down here a little. And if you look at the top of each column, they're numbers. And they're Roman numerals. And the ones you need to know on the test, I guess I didn't do it for the first one, but I will now. In case you couldn't make it out, now you can. If you're not familiar with Roman numerals, like IV is 4, that's the number you should also. Now, you will be given this, and the numbers, both in Roman and standard numerical, will be given to you. Now, if we look at the alkali metals, and the question is, how many valence electrons does lithium have? And the answer is 1. You look at the top there. By the way, even though hydrogen is not considered an alkali metal, it also has only 1 valence electron. Now, once you know 1, you know them all. If lithium has 1 valence electron, How many valence electrons does sodium have? Same. Look at the top, 1. If we look at potassium, how many valence electrons does potassium have? It's right here. Look at the top, 1. Isn't this much easier than electron configuration? And but I wanted to teach you that, but orbital diagram, this is more important. Now, if we come over to calcium, you know calcium is good for strong bones, and how many valence electrons does calcium have? Look at the top. If you don't know Roman numeral, I give you the standard number, 2. Oh, I should share the fun. How many valence electrons? Well, 1 or 2 points each if you see it sometime in the future on a piece of paper I hand out, test. How many valence electrons does magnesium have? First of all, you have to know the chemical symbol, Mg. And if you look at the top, you'll see 2. Let's go over to this side of the periodic table so it doesn't feel left out. You people don't feel left out that I'm standing on that side, but that was like. But anyways, my favorite, carbon. I don't even have to look. How many valence electrons? I'll let you figure it out first. Does carbon have? Time's up, and 4. Did I get it right? I did. And look at the number on top. Now, let's make it more realistic. Somebody's going to invent a whiteboard where you just press a button and it all gets erased. Not today, though. Probably dry marker. All right. Sometime in the future, 1 to 2 points each, how many valence electrons are in. I'll do the first one, and I'll let you have fun so you can do the other ones. And it'll be a nice start to your weekend, having fun with valence electrons. And the first thing you have to know is what's the chemical symbol for oxygen. It's O. You don't have to write that down. And then you have to find it on the periodic table. It's right here. Then, for valence electrons, you have to know, look at the top, either VI, which is the Roman numeral for 6, so I also have 6 there. And that tells you oxygen has 6 valence electrons, and this is the number you write down. And now I'll let you try these other 3, bromine, nitrogen, and argon. If you haven't learned the chemical symbols today, I'll help you out on the test. I won't. Have fun. Again, you're trying to find out how many valence electrons, the outermost electrons, each of those elements has. you have any questions, I'll be staying after today, but today I have to leave to have an appointment. But I can spend about 10, 15 minutes after class if you have any questions. Also on Tuesday and Thursdays, I try and keep my schedule clean. So after lab, which we usually finish early, I'll stick around if you have any questions always. All right, let's do this. Question is, how many valence electrons are in the following elements? And don't forget, valence electrons, the outermost electrons of an atom. And if we look at bromine, chemical symbol Br, it's a halogen. And if we look on top, the number, Roman numeral VII, is 7, or the number 7, and that tells me bromine has 7 valence electrons. Nitrogen, chemical symbol you should know is N. It's right here on the periodic table. Look at the top. This is atomic number. That tells you electrons and protons, not valence electrons. Valence electrons are only the electrons in the outermost shell. We look at the top for nitrogen, we see the number 5, and we know there's 5. Remember I told you the maximum number of valence electrons is 8. If we come to argon, it's in noble gas. Look on top, 8. And that's how you figure out valence electrons. Any questions on this? Isn't it simpler than electron configuration? But hopefully you got electron configuration down. If not, see me. Now, if my memory serves me correct, and I think it does, 2 weeks from today will be test 1. I have covered all the material in test 1, but next week we'll go through the problem set in lab for both Tuesday and Thursday for chapter 2 and the appendix A2 and A4. I highly recommend you do them on your own first. Then the following week, I'll go through in the lab chapter 3 problem set. At the end of that week, Friday we'll have the test in here. Also, the Wednesday before the test, I will do my world famous review for the next test. And you'll find out it is world famous notes. But students say it helps them, so I do it. So, what that means is, it's time for a new chapter. In the syllabus, I have chapter 11. I can skip that and cover it later. And we're going to talk about chapter 4, chemical bonds. And when we talk about chemical bonds, the material I'm covering now will be on test 2, not on test 1. But I have to keep on moving forward. And it happens in the semester and also during the summer. It's even worse because it's faster accelerated. But anyways, when we talk about chemical bonds, an important thing is called Lewis structure, sometimes called valence dot structure. I like to honor Dr. Lewis, who came up with this idea. And a Lewis structure, I'll never ask on test what is a Lewis structure, but I'll expect you know how to do it. And that is, it consists of an element symbol with 1 dot for each valence electron. And valence electrons are never D and F orbitals, they're just S and P. It turns out that way in nature. And so, how do you do a Lewis structure? Important part, when you're doing a Lewis structure, you place 1 electron on one side of the symbol, chemical symbol, before you double up. And if you think about it, how many valence electrons are maximum? 8. Well, the symbol has 4 sides, that's the maximum you could put on. So let's do Gesundheit. By the way, my grandmother Greenman trained me well. You don't know what that is? Look it up on Google. By the way, generation gap, I don't use Google as a verb ever. I try not to. If you don't know what a verb is, well, look it up on Google. It's Lewis practice time. And the question is, 3 points each or 2 points each. Write the Lewis structure for sodium, magnesium, carbon, oxygen, bromine, and argon. I don't know if we'll get to all of them. But how do you do that? And something on test, I'd give you a couple of those. I wouldn't give the chemical symbols. I'd write down sodium, magnesium, and carbon, and you should know those. So, let's look at how you do a little structure. First of all, you need a periodic table. We look at the first one, sodium. How many valence electrons are in sodium? 1 valence electron. How do you know? You look at the top of the column sodium is in. Not this number, it tells you total electrons. You look at the top for valence electrons, which are outermost. It has 1 valence electron. I have the chemical symbol. How many dots do I have to put? 1. And I can put it on any side. Doesn't matter. Today, I'm going to put it on top. I could have just, that's an ugly dot. That's better. Not really. But anyways, I could put it here, here, here. I just put it there. Let's look at magnesium. First of all, you have to know the chemical symbol. Where is it? Magnesium is right over there. Look at the top. You see the number 2. So you have 2 valence electrons. You don't have to put this down, but I'm showing you where I get these dots from. And therefore, Lewis structure. Put the chemical symbol. And then you don't double up dots until each side has 1. You don't double up dots until each side has 1. So I could put 1 there, 1 there, there. The second one, where under many combinations. I could do this, I could do this, and I could do a whole bunch more. Luckily, I have a piece of paper signed by the Board of Regents of Michigan State University. I understand all of those. And there are many variations. If we look at carbon, how many valence electrons? 4. How do you do a little structure? And now, I'll take carbon, and you put 1 on each side. You do not double up until each side has 1 dot. That's the rules of how you do the structure. Ooh, I got time for 1 more. I'll move it up here. Let's do oxygen. Oxygen. How many valence electrons? I'll let you figure it out. I'm being tough on you today. Time's up. Oxygen. How many valence electrons? Not that number. Number on top, 6. So oxygen has 6 valence electrons. Now watch closely. Chemical symbol. When you're putting in valence electrons, you put 1 dot on each side. So I can do this. Oh, my dots are getting better. But anyways, I have 4 electrons. I'm supposed to have 6. I have 2 more to go. I can put it on any side. Organic chemists usually write it this way. You could have easily written it this way. And there are other variations. And that's how you do a Lewis structure. And this helps us understand chemical bonding. And I'm going to let you out a whole 35 seconds early. Have a great weekend. Don't forget to work on your problem sets.